Hi, this is Mr. Cappert. I'm going to go through statics. There is one worksheet that goes along with this. Do background research, statics. Now, statics is a branch of mechanics. It is a physical science that deals with the response of bodies to the action of forces. So, underneath mechanics, you have statics. That is when the bodies are not moving, they're at rest, and everything is assumed to be rigid. Dynamic is when the bodies are moving. That's a totally different class. If you were in college, these would each be different classes. Strength of materials is when you actually start to not assume that the bodies are rigid. You start to look at how the steel bends with the force. With statics, though, in our bridge, we're not going to study how the basswood bends. We're going to assume that it's fully rigid, which is not true. And the last mechanics class would be fluid dynamics, which would deal with the flow of fluids such as water around a bridge. In statics, this is the easiest of these classes. Everything is assumed to be stationary, so all of your forces when added together should equal zero, net force of zero. And the forces cancel out and are said to be in a state of static equilibrium. Here's an example of the Statue of Liberty, which weighs 496,210 pounds. This is its weight. Pressing down and then pressing up is the base of the statue with the exact same force, 496,210 pounds. Now, I'm going to show you guys how to do this with your bridge. What this says is the summation of the forces in the y direction, straight up and down, is equal to the weight of the bridge plus this force N, normal force, the base. Since your weight is going downwards, that is going to be negative. Since the base, the normal force pointing up is positive, the positive y direction, it is positive. And look, they cancel out to zero. It's static. So the steps to finding unknown forces is that you define your positive x and y directions. You sum all of the x components equal to zero. So this symbol means summation of forces in the x direction. Summation basically means add. Add the forces in the x direction. So this would just be a random force in the x direction. If you have a second force in the x direction, this is it. You third, this is it. Fourth, just keep adding all the x forces. Sum all the y components to zero. So summation, the addition of all the forces in the y direction. Start adding up all of the forces that go in the y up and down direction. And then you would use algebra to solve for unknown forces. Our bridges are going to be super simple. We are just going to find the support. We are not going to find all of the forces in each member. You could do that, find the member forces. That would take forever. Here is an example of a bridge. On a bridge, you always have one side that's a pin, so it is fixed. It cannot go back and forth. So it's both holding the bridge up and it's holding it from going back and forth. Now you have the vehicle that is pointing down, force of the car is downwards, the weight of the bridge is downwards, and then you have a roller which only holds the bridge up. It cannot hold the bridge from going back and forth in the x direction. So the first step is to take this picture and replace all the objects with the force. You don't want the car over here, just show the force of the car. Here's an example of rollers on bridges. So you may have never noticed these before, but if you look closely at a bridge, one side will have a roller to allow for expansion. Here's an example of a 1,000-pound car parked in the center of a truss bridge that weighs 5,000 pounds. So in order to draw a free body diagram, you ignore this pin and roller and car. You replace them with their force. So the pin has a force in the x and the y direction. Doesn't matter which way you draw this A of x. Now the naming A of x, A of y is because it's at pin A and it's in the x direction. It's at pin A and it's in the y direction. This is at pin E, and it's in the up and down Y direction. And then you draw in the weight of the bridge, force of weight, that's what the W is, and the force of the car, 1,000 pounds going down. First step here, add up all the forces in the X direction. Okay, you have A of X and no other force, so it equals 0. There is no wind for it to counteract, so that is why this is 0 in this case. One of your problems has wind, and in that case you would want to either add or subtract the wind, and then this will be supplying a force. Then you want to sum up all the forces in the Y direction. So you have negative 5,000 pounds because it's going down. You have minus 1,000 pounds because it's going down. You have plus this force AY because it's going up, holding the bridge up, and plus EY that is going up, equal to 0. Now, you can do the algebra here and you'll get AY plus EY equals 6,000 pounds. Since the weight is in the exact center, just split that in half and each is supporting it by 3,000 pounds. Yes, this seems like a lot of work for something that you wouldn't even need to write out in this fashion. But if you ever take a statics class, this is the first step. You'll have things that are much more advanced. And last year I did, if the car was over here, parked in the middle here, 5 meters out, this would become much more complex and you would need another equation and it wouldn't be so easy. I hope this helps. If you need more help, let me know.